Hi everyone, let us discuss this example. So in this example, we have this equation and we have to solve it. That means simply we have to find its roots. So let us write a given equation first. What we have? We have z raised to 8 plus z raised to 5 plus z cube plus 1 is equal to 0. Okay. So here the highest power of z is 8. So obviously it will have 8 distinct roots. Okay. So let us start to find. What will I do? See, from first two terms, we can take z raised to 5 common. So let me write here z raised to 5 in bracket. If you take z raised to 5 common, you will have z cube plus 1. And from next two terms, we cannot take common. So obviously 1 we can write as a common term. So we will have again z cube plus 1 is equal to 0. So here we have z cube plus 1. Here also we have z cube plus 1. So we can take that bracket common. So if you take z cube plus 1 common, here z raised to 5 is remaining and here 1 is remaining. So we will have product of these two brackets. So you know that product of two terms or two real numbers is 0. That means you can take complex also. So here product of two terms is 0. That means either first one is 0 or second one is 0. Okay, so let me write here. So therefore z cube plus 1 is equal to 0 and z raised to 5 plus 1 is equal to 0. Now we have to solve these two equations simultaneously. Here the highest power of z is 3, so it will have 3 distinct roots. Here highest power of z is 5, so it will give 5 roots. 3 plus 5, we will have total 8 roots. We want 8 roots, right? Since the highest power of z is 8 here. So let us focus on this equation first. So let me write here, consider z cube plus 1 is equal to 0. Let us shift 1 on that side, so we will have z cube is equal to minus 1. So now what will I do? We will try to express that complex number in its polar form. So for that we need to find r and theta. So tell me first what is x and what is y here? X, real part, minus 1, y, imaginary part. But see, I, complex number I is not there, so its imaginary part will be 0. So let us find r. So you know that what is the formula to calculate r? Square root of x square plus y square. Square of x is 1, square of y is that means 0 is 0. So we'll have root 1 which is 1. Let us go further. Let us find theta now. Okay, so let me write it here. So theta is equal to, so actually theta has 4 different formulas, right? If that z lies in the first quadrant, we have a separate formula. For second quadrant, for third and for fourth quadrant also, we have different formulas. So let us find where that point lies. The point is minus 1. Okay, so minus 1, that means it lies on a negative x-axis. It lies in negative x-axis. So let me show you here. So suppose you have a diagram like this. This is x-axis, negative x-axis, y-axis, negative y-axis, right? See, you can call it as real axis, okay, imaginary axis in that way also. So minus 1 we have, so their imaginary part is 0, real part is minus 1. That means that point will be here. It will be on that real axis or negative x-axis. See, therefore, we can use the formula either for which is applicable for second quadrant, or you can use the formula which is applicable for third quadrant. I will go for the formula for second quadrant. The formula is pi minus tan inverse of mod y by x. So this is equal to pi minus. We need to put the values of x and y. What is our x? Minus 1. So the denominator is minus 1. What is value of y? 0. So the numerator will be 0. You know that 0 upon any non-negative, non-zero number, you will always have 0. So therefore, tan inverse of 0. But see, tan 0 is 0, so that's why tan inverse of 0 is also 0. So value of theta is pi. Okay, so theta is pi. So therefore, we can write z cube is equal to minus 1, but the same complex number can be expressed in polar form as follows. You know that r means 1 here, cos theta, cos pi plus I sin theta, that means sin pi. So now I express this complex number in its polar form. So this is equal to 1, no need to write cos. We can write here 2k pi plus I sin. Here also I can write 2k pi plus pi. Okay, so same thing we have already done in our previous videos, so that's why definitely you know the reason behind it. 2 pi, that means 1 complete circle. 2k pi, that means k complete circles. So if you have any point, if you complete k complete circles, then we reach at the same point. So that's why if you add 2k pi in angle, you will have the same point. Let us take cube root of both sides. So here you will have z. If you take cube root, cos, here we can take pi common. So 2k plus 1 pi, plus here also I can do the same. I can take pi common, 2k plus 1 pi raised to 1 by 3. After that, I am going to use De Morvis theorem. That theorem says if you have cos theta plus I sin theta and bracket raised to n, then you can write n as a multiple of that angle. So here n is 1 by 3. So by De Morvis theorem, we can take a product with this angle, okay, of that 1 by 3. So we will have cos 2k plus 1 pi by 3 plus I sin 2k plus 1 pi by 3. Okay, so obviously here where I should mention k varies from 0, 1, 2. As I told you the reason in previous video. So see here what we are solving, z cube is equal to -1. So obviously we will have three different roots. So that's why I should vary k from 0, 1, 2. If you take k is equal to 3, then you will have the same root which we get for k is equal to 0. I will put first k is equal to 0 to get our first root. See, for k is equal to 0, I will call it as z0, okay, the first root. Say I'm putting k is equal to 0, so we'll have cos pi by 3 plus I sin pi by 3. Let us put k is equal to 1 now. For k is equal to 1, z1 is equal to, I'm putting k is equal to 1. What will we have? Cos, I'm putting 1, so 3 cancel, cos pi plus I sin pi. Okay, so sin pi is 0, cos pi is -1, you know, so its value is -1. Let us go for the last. For k is equal to 2. So k is equal to 2 I'm putting, so we'll have z2 is equal to, here you will have cos, I'm putting 2 here, so we'll have 5 pi by 3 plus I sin 5 pi by 3. So in this way we got three distinct roots, right? So we solved this equation z cube plus 1 and we got these three distinct roots. Let us go for the second equation. What is the second equation? We have z raised to 5 plus 1. In the same way, we will solve that equation also and it will give us 5 distinct roots. These 3 plus those 5, we will have total 8 distinct roots. Make a screenshot of it, then we will go further. So now we have z raised to 5 plus 1 is equal to 0. Okay. So therefore, z raised to 5 is equal to -1. So now we have to convert this -1. We have to express this complex number -1 into its polar form. We have already done this thing for z cube plus 1 is equal to 0. Okay, but we will repeat, no problem. So x real part -1, imaginary part, no imaginary part is there. So 0, r, you know the formula for r, square root of x square plus y square. Putting x is equal to -1 square, 0, we will have obviously 1. So now for theta already we have calculated, right? So the same theta we will have. So let me write directly pi. So therefore we can express z raised to 5, which is -1, as r 1 cos theta, that means cos pi, plus I sin theta, that means sin pi. Now what will I do? I am going to add 2k pi in this angle. Okay, so we will have cos 2k pi plus I sin 2k pi plus pi. Reason is same again, right? So if you complete k complete circles, we reach at the same point. So that's why we can do it. After that, what will I do? I will take fifth root of both sides. Let us do. So z is equal to, by taking fifth root here, you will have z only, and cos, let me take pi common. So 2k plus 1 pi plus I sin 2k plus 1 pi and whole raised to 1 by 5. Okay. Again, I am going to apply De Morvis theorem. It says you can take this 1 by 5 as a multiple of that angle. See what will you get? So this is equal to cos 2k plus 1 pi by 5 plus I sine 2k plus 1 pi by 5. So now the question is which values of k we have to take here. How many roots we want? 5, obviously, getting since z is to 5 we have. So k always starts at 0, so I should write 0, 1, 2, 3, 4. So it will give 5 distinct roots. If you take k is equal to 5, again you will have the same root which we get for k is equal to 0. If you take k is equal to 6, you will have the same root which we get for k is equal to 1. Okay, so yes, these are enough. So let us put k is equal to 0 first. Okay, let me write it here. So for k is equal to 0, I am calling it as Z4. Okay, Z3, sorry, Z3. Since on Z0, Z1 and Z2, these 3 roots already we have got for previous equation. So I am starting from Z3. Let us put k is equal to 0. So cos, let me write here, cos, I am putting k is equal to 0, right? So here we will have pi by 5 plus I sine pi by 5. Let us take cos k is equal to 1 now. Okay, so if you take k is equal to 1, so you will have yes, cos z4 is equal to cos, I am putting, so 3 pi by 5 plus I sine 3 pi by 5. Okay, so for k is equal to 2, so we will get z5, fifth root. I am putting k is equal to 2, so cos, I am putting k is equal to 2, 2 plus 4 plus 5, 5 will get cancelled. So cos pi plus I sine pi. See, cos pi is -1, sine pi is 0. We are getting the same root. -1 already we had got, right? For the previous equation, zq plus 1 is equal to 0. We are getting the same root. That root is repeating here. So for k is equal to 3. So we'll have the 6th root. I am putting k is equal to 3. Yes. This is actually 7th root, since we have started with z0. So this is 7th root. Let us put k is equal to 3. So cos, I am putting k is equal to 3. Here we will have cos 7 pi by 5 plus I sine 7 pi by 5. For k is equal to 4, the last root z7 for k is equal to 4. Let me write here. Cos, here at 9 pi by 5, cos 9 pi by 5 plus I sine 9 pi by 5. Okay, so yes, so Z0, Z1, Z2, Z3, Z4, Z5, Z6 and Z7. Total 8 roots we have got. Okay, make a screenshot of it, then we will stop. Thank you. Bye bye.